So welcome everyone to this XAIDA workshop on tools for agriculture. XAIDA stands for Extreme Events, Artificial Intelligence for Detection and Attribution. So I'm going to spend a couple of slides explaining the basics of detection and attribution first. The field of detection and attribution is still relatively new, with the first papers coming out in 2004, about a year after a very extreme heat wave in Europe that many of you might have heard about or even experienced. So in that study, they looked at very large areas and also very long temporal periods, going over the whole of the summer. And since then, the field has advanced, and we can now look at much smaller spatial scales, so really going into the scales that impacts the impacts are affected by, and also temporal scales, not taking a whole of the seasonal mean, but really looking at daily maxima, such as in this event, the Pacific Northwest heat wave from 2021, where there were very extreme impacts, and the headlines were really dominated by the record-shattering event of this heat wave. So as with this event, the typical question is, what has this got to do with climate change? Can we attribute this event to climate change? And when we do such a study, then we split typically this question into two parts. The first is known as detection, and then we want to see what evidence is there. Are events like these changing in frequency or magnitude? And the second part is attribution, where we say to what extent is that change attributable to climate change or to some other factor. So the first part, detection, we look at the real world. And of course, there's a lot of natural variability in our observations of the world. So the question is, can we actually detect a trend in the variable of interest over and above natural variability? And in this case, you can see that there is a trend in the annual maximum T maxima. The actual event itself is way above that, but there's clearly a trend there. And then we can translate that trend into a change in frequency and a change in magnitude for that event. Quite often in studies, we will compare that to plot the same observations against GMST as a proxy for global warming. So we can see that there's a nice linear relationship between all the previous events. But that doesn't tell you if it's actually due to climate change or not. And for that, we need a controlled experiment, which we can't do with our real atmosphere, but we can do with climate models. So that comes when we come to the second question, attribution. And here's an example of a model ensemble, and you can see that the model generates a lot more data than we have in reality, and that allows the signal to noise ratio to improve. And if we have good agreements between the models and observations, then we can also reduce the uncertainties. And in these simple experiments, then we're comparing today's climate with the past, but with a model run, you can of course extend the run into the future and then also look into projections. And with XAIDA, we're looking at all these three things: detection, attribution, and projection. But these examples have been very simple in nature, and in the real world, there are many challenges in attribution, such as the data quality and variability. We have in some regions very poor data with missing measurements or short data sets, or we look into variables where there's a lot of natural variability, and all these things impede detection. As you can see on the right, there's a figure with stations for precipitation data that have time series of 50 years or longer, but there's many parts of the world that don't have so much data, and so doing an attribution study there would be very challenging, maybe not impossible, but often a big challenge. Then there's rare or very rare or yet unseen events, as we saw with the Pacific Northwest heat wave. You might imagine, can that happen in my town? It hasn't yet happened, but we need lots of data around those events. And the current climate models as they stand don't have enough data. Then there's compound and cascading events, which typically happen around extremes. Extremes are caused by many things coming together, but there's no standard way to address that. Then as we go to smaller scales, we can begin to address impacts. And many of you are very interested in event definitions related to impacts, so that's something we've been busy with. And also we want to condition on dynamical processes to reduce uncertainties and to increase our process-based understanding. So coming to XAIDA, XAIDA has an overarching goal, which is to develop new artificial intelligence methods to study how global warming affects extreme weather worldwide. It's a 4-year EU-funded project, and we're over halfway through now. It unites 16 climate research institutes within Europe, and we collaborate with a range of stakeholders, and we also develop new educational material together with teachers. So some highlights so far, which relate to those challenges that I just showed. XAIDA is advancing detection and techniques for low resolution data, for example, convective events and hurricanes. We've been looking into unseen and no longer seen events, such as very cold winters. And we presented some of that information in our Cities and Energy workshop. Then there's compound events, for example, heat and drought, or cold and wind drought, which is important for the energy sector. And then finding new impact-based and process-based event definitions, which we'll hear a bit more today about in the agricultural workshop. So our outline for today will be 5-minute presentations, followed by 10 minutes of questions on those presentations. And we're going to start with the machine learning toolbox XAIDA and the web platform KNMI by Gustav. And then second, there'll be a presentation on vegetation predictor EarthNet. And Claire Robin is going to take that talk because Marcus Reichstein couldn't make it today. And then we'll end with open discussion and feedback. So questions that you can think about asking during the presentations are, do you have any suggestions on how to make these methods more applicable to your needs? And what do you yourself need for this sector? What kind of requests do you get? And how useful would these methods be if they are operational? What do you see is currently lacking and what would be needed?